Okay, we move on to Patricia Goncalves. She has two presentations, and she had a presentation also this morning. So, this is great. Okay, the first one is on batch fecundity, and the next one is on post-ovulatory follicles. Are you just continuing then?
We can make a
You have a question in between? Okay.
If you want.
Yeah.
Good afternoon to all of you. This work, as Olav was saying, is about batch fecundity estimates in horse mackerel. I'll show it at the morning. This is the general equation of the DPM, and we intend to estimate the F. Batch fecundity is the number of eggs released per female in a single spawning event. Okay, we are using on our DPM samples the hydrated oocytes method to estimate batch fecundity. What we started to do is select our samples. We make histology, and on each slide we identify the presence or absence of migratory oocytes on migratory nucleus stage, on hydrated oocytes, post-ovulatory follicles, and atresia. After that, for batch fecundity, we select the samples with hydrated oocytes but not new POFs. That ones are excluded for our estimates of batch fecundity. After the samples are selected, we cut 3 pieces of more or less 0.1 grams each from one lobe of the ovary. We act, and the hydrated oocyte is counted under the stereoscope. After that, the mean number of hydrated oocytes per gram was then extrapolated for the ovary free weight of the female. This is what we call our traditional method. As Costas has been saying, new developments on recent years have been published. And based on this particular paper from 2010, we decided to make a similar approach to our horse mackerel samples. These are the objectives of our study. We intend to estimate the batch fecundity on horse mackerel. First, using the hydrated oocytes methods and counting the hydrated oocytes by the two approaches, traditional method versus image J. The second aim of this study is explore the hypothesis of using other spawning markers to achieve on this species the batch fecundity based on the image J analysis results. Okay, firstly, this is what Maria more or less explained it before about the application of image J. Of each piece of ovary, we take a photo. We try to fit all the oocytes of that piece on the same photo. We have to be careful and separate it because some aggregations can be counted as one. After we transform our image in A8B, and we apply the threshold, watershed, and we define the size range of the oocytes to be counted and the circularity of the particles. And this is our results. The image J counts all the particles that have been defined previously. This is an example of an count of the oocytes with the two methods. You can see that we obtain the same result. This is for all the samples we have. Traditional method counts of hydrated oocytes versus image J. They fit very well. And if we apply our results to obtain the batch fecundity estimates, the results are also very good. Okay, why we intend to explore other spawning markers? This is a table of our APM surveys, and you can see here our number of spawning females that we achieved in each one of them. we have an exceptional amount of samples in 2004 March, because I think we found an aggregate school of hydrated females. That's why we catch so many. We have this problem. We just normally we get so few samples, and it's difficult to adjust a model with that number of samples. And to try to see if we can use another spawning marker to achieve a well estimate of fecundity, we started to look to our histology results and to select all the samples that has been identified the presence of migratory nucleus stages. And we get, on that conditions, 39 ovary samples. After that, we cut a piece approximately with 0.1 from one lobe of the ovary, and we apply the same process. We take a photo of the oocytes, be careful because they don't have to be so much close, and the program automatically measure and counted every oocyte in that image. Okay, this is our results and a part of our method. We plotted the whole oocytes distribution by size of the 39 ovary samples. This is oocyte size distribution of horse mackerel from a previous publication of Gord et al. And we can see here that according to this, the comparison of the figure of the paper with the oocytes vitellogenic and pre-vitellogenic, that in our data we miss the pre-vitellogenic ones because there are too transparent. And when we take the photo and apply the 8 bits and threshold, and because we are using also lower magnifications, we miss the lowest ones. Now we are just looking at the vitellogenic phase of our gonads. When we look for the results, we see in every samples a peak, and in the 200 areas, millimeter square areas. And this is correspond of our early migratory nucleus stage phase for horse mackerel. And we try to see what will happen if we select all the oocytes that are above that size and we sum them. And let's see what it happens if we can estimate fecundity based on that. Okay, we have identified our spawning marker, and we'll go to obtain the number of oocytes by these sums, and then extrapolate it for the ovary free weight of the female. And these are the results that we obtain. Here are plotted the observed batch fecundity obtained applying dehydrated oocytes as spawner markers and the migratory nucleus stages as spawner markers. We can see that the results with the migratory nucleus stage are very similar to the other ones. And we try to do another thing, because our problem is that we have few samples. And what if you combine the two estimates for the two spawning markers for our data? And this is our results. I think they are okay. Okay, after that, we are applying our model based on the ovary weight free and the observed batch fecundity to our real population. We use the same methodology that is being applied for anchovy and sardine. After we have our model adjusted based on our observations, we extrapolate it for all population. We adjust our model for based on the ovary free rates of the other female sampled, and we get our fecundity estimate to be used on the DPM model. This is our results with the three methodologies. We can see here our fecundity estimate based on hydrated oocytes method, based on migratory nucleus stage method, and based on the two combined. The results, I can say are very similar. But all of these results are based on our samples from the Portuguese DPM 2010. And you know, when we're planning a survey, we have big expectations of what we can get from the data. We always think to get more data that in real we can get. And we have a question, how well our DPM sampling represents our population for the horse mackerel stock? Let's see. We decided just to make a small exercise. We have the abundances by age for the assessment, given by the assessment, and we have the mean height by age, and we use that to assess our fecundity for our real population. And that's what we get. We can see that based on the assessment and based on our DPM estimates, the values are very similar. Maybe we are covering very well our population during our survey. Okay, just to finish, we can conclude that our ImageJ automatic analysis has been successfully used to estimate F in horse mackerel. As well, can be applied in another spawning marker, migratory nucleus, and we can also use the data combined from those two spawning markers. But we have further work. I think we can make the same exercise with other vitellogenic oocytes to see what you get and explore the relations between the ImageJ data and the identifications by histology. This is just a small example. This is our image of our section, histological section, and this is the data given by the ImageJ. You can see here we have the two cohorts quite defined. Okay, and just to finish, I have a question. Are we a step closer to avoid histology sampling procedure from our DPM routines? Let's see. Okay, thank you very much for your attention.